Hi guys. Okay, welcome. So in today's lesson, we are going to look at what we can refer to as absolute value equations. So what we are going to do is we are going to learn how to actually solve equations which are associated somehow with the absolute value function that we have seen in the previous lesson. You see. So one thing that you have to know when it comes to the solution of or to solving equations that have absolute functions in them is that there are many different ways in which this problem can be solved. And to list one of the common techniques that can be used to solve these problems are we have what we call the squaring technique, or which we can simply refer to as the squaring method. And then we have what we call the method of cases. And then also the other thing that we have is what is known as the graphical method. You see, so we have all these various ways which can be used to solve these different types of equation. So what we are going to see mostly in this lesson is I'm going to demonstrate how to solve these type of equation using the squaring method and also the method of cases. So the graphical technique, I will just do it in another lesson separately from these, you see. So yeah, that's what we are going to learn in this lesson. So to begin, first let's understand what is an absolute value equation anyway, you see. So an absolute value equation is an equation of the form. So an absolute value equation is an equation that has the form alpha times f of x plus beta plus is equals to maybe alpha prime some function g of x plus beta prime, you see. So what we refer to as an absolute value equation is usually an equation that has this structure like this, or at times we don't have to have all the functions living under the absolute function, so at times they can just come in the form you see. So that's what we refer to as an absolute equation. So an absolute equation, value equation, is an equation that has this form. So examples of absolute value equation are things like this. Maybe solving the equation 3x minus 1 plus 4 is equals to 2x minus 5, or maybe the absolute value of x minus 3 is equals to 4x squared minus 1. So all these are typical examples of what are known as absolute value equations. So every time when you come across equations like these are what we refer to as absolute value equations. And what we are going to do now is we are going to see how actually one can solve these equations using the various techniques that we have already mentioned at the beginning of this lesson, you see. So the next thing now that we are going to look at is learning how to solve this equation using the squaring technique. You see, so what exactly is the squaring method when it comes to solving absolute value functions? You see, so the squaring method or the squaring method is a method which is based on the following result. So what we refer to as the squaring technique for solving absolute value equation, it is a type of technique that uses the following result. So what you should know is that what we call the absolute value of some number is the same thing as just saying the square root of that thing squared. So this is actually another way of defining what is known as a square root in some cases, you see. So now at this level, it is time for you to actually get to know what is the correct definition of the square root. Most people, they understand the square root of some number as the plus or minus something. Like if you ask someone what is the square root of 4, they would respond and say the square root of 4 is plus or minus 2, but that's not actually true. The square root of any number is a non-negative number. You see that? So the square root can never be negative, it's always non-negative. And the proper definition of the square root is exactly what we have provided here. So what you see here at this top is actually the definition of the square root. Showing that the square root of any number is always greater than or equal to 0. You see, so what we refer to as a square root is something that can never be negative. So a square root is a non-negative number. So from this definition of the square root actually lies behind a technique that can be used to solve absolute value equations. So it's good to pay attention to it, because now we are actually going to demonstrate how exactly can we employ this result into solving absolute value equations. You see, so to do that, let's move on now to look at some different problems for which we can apply this result. So the first problem that we are going to look at, it goes as follows. You see, so we are asked to solve the following equation. So we want to solve the equation 5x plus 3 is equal to 2x minus 1. So that's the problem that we have at hand. We are given this result and we are asked to find what the solution of this equation really is. So how we're going to proceed now is as follows. So at first we'll recall that the absolute value of any number is the same as just saying is that squared. So knowing this, it means that the left hand side of the equation given above can actually be written as the square root of 5x plus 3 squared, and also the right hand side as well can be written as 2x minus 1 squared. That's what we can see now. You see, so we now know that every time in maths when we have the square root both sides, we can remove this by squaring on both sides. So if I were to square on both sides, what I'll just remain with is what I remain with 5x plus 3 squared equal to 2x minus 1 squared. So it is at this point where we see actually that behind this definition lies the squaring technique, because if you are to look at this line, it's more like it was obtained directly from taking that equation and squaring on both sides. So now we achieve that. So now what we can do is we can expand on both sides and let's see what we get. So we'll get 25 x squared then plus 30 x plus 9 equals to 4 x squared minus 4x plus 1. So what then happens next? So the next thing that happens next is we take 4 this side, then we get 21 x squared, then plus 34 x. Then if we take that 1 and we bring it this side, we can see now that we get plus 8. All this is equal to 0. You see. So now having obtained this, the next thing that we can do now is we can see that already this is a quadratic equation. So you can use or employ any suitable technique that you usually use for solving these type of problems. You see. So what we're going to do now is we can employ for much ease the formula. So we know that x is the same as just saying minus 34 plus or minus root of 34 squared minus 4 by 21 by 8, and then all this over 2 by 21. So this is what we obtain. Now what we can do now is we can try and see what we get when we are to punch that result on a calculator. So what do we get? So I have here at the bottom 34 squared subtracting 4 with 21 and 8. This gives us 484. So if you simplify that, it will give you 484, all this over 42. Then we have now negative 34 plus or minus. So what we can do now is we can find the square root of the answer, which comes out to be 22 in this case, all over 42. So now we know that we can therefore start our simplification, where we get x is equal to what? So let's simplify the two solutions that we have. So if we apply our calculator, you will see that one of the solutions that you are going to get is that x is equal to 4/3 or minus 4/3, or x is equal to what? So the other solution is 22, then divide by 42. So the other one is negative 2/7, like that. So these are the two values of x that we have. Actually, using therefore here can be misleading, because it will make someone think that actually this is the final conclusion to this problem. So remember, the problem that we were given at first was not a quadratic equation, though at the end it turned out to be a quadratic equation. But let's not forget that originally what we started with was not a quadratic equation. So which means every time when we get two solutions like these, we have to revert back into the original problem and see which of these actually is the correct solution, because it can happen at times that the solutions that we have, they are not both correct. One is fine, the other one is not a solution to the problem. So what you simply do to verify that what you have obtained the correct solution is you take each and every one of them and go back to your original equation and see that if you substitute these two solutions on each of these sides, you always get the correct solution. So now what we're going to do is we're going to check up and see that everything that we have is working out pretty well. So now I will do what is called checking, though this step is not necessary when you are solving problems. So to check, let's consider the equation that we have. We have 5x plus 3, 2x minus 1. You see that? So now let's check when x is negative 4/3 and see what happens. So let's put negative 4/3 into the left hand side. So if you put negative 4/3 here in the left hand side, since you are putting negative, you will get negative 20/3 plus 3 is equals to absolute value. So we're putting negative 4/3 anyway, so we'll get negative 8/3 minus 1. And this implies what? So let's simplify. So if you simplify on the left hand side, what do we see? So we see that we'll have 9 minus 20. So what is 9 minus 20? It's minus 11. So we get minus 11/3. And this is equal to negative 11/3. So we see that right hand side is equals to left hand side. So therefore this x is a solution, you see. So therefore we can conclude that x is equals to negative 4/3 is a solution. So this working is not something that you should show, as I have mentioned, when you are solving this problem either in test or exam, but it's good now as practice to always verify that what you obtained is actually the correct solution that you are looking for. So let's check also the other solutions that we have. So we'll come now and say what happens now when x is equal to negative 2/7. So when x is negative 2/7, we can put our things there. So when we put negative 2/7 on the left hand side, we'll get negative 10/7 plus 3 equal to 2 and negative 2/7, which will give us negative 4/7 minus 1. So what happens now? We get here. So we have 21 minus 10, which gives us negative 11. So we say negative 11/7 equals to, again, we get negative 11/7. So we see now that the left hand side is equal to right hand side. So therefore, x equals to negative 2/7 is also a solution. You see. So therefore, what can we conclude? So therefore, solution is what? So solution is x is equals to negative 4/3, or x is equals to negative 2/7. You see. So these are things that you must make sure that you understand every time when it comes to solving problem using the squaring technique. So this is how you employ the squaring technique for solving absolute value equations. So just to see it again, let's do another example again for more practice. So the example that we have now, it goes as follows. Solve the equation 2x minus 5 equals to 3x plus 4. So let's say now we want to solve that. How do we proceed? So to solve this, this is how we proceed. So remember, from our definition, let's recall, from our definition we've already stated that the absolute of some number is the square root of the square of that number. So this implies, employing this definition on the left, we'll have that the square root of 2x minus 5 squared is equal to the square root of 3x plus 4 squared. So squaring both sides, we'll have 2x minus 5 all squared is equals to 3x plus 4 all squared. Then squaring both sides, again, what do we obtain? So we get 4x minus 20x plus 25 is equals to 9x squared plus 24x plus 16, like that. So let's simplify now. Sorry, it's 4x squared here. Then what I'm going to do now is I'll take everything on the left and put it on the right hand side. So I'll have 9x squared subtracting 4x squared, which will give us 5x squared. And then I'll take negative 20. That side becomes positive, so we get plus 44x. Then I will have 16 minus 25. So if I have 16 and then I subtract 25, we get minus 9. If I'm not mistaken, so 16 minus 25 is minus 9. So we get minus 9 is equals to 0. So now having this, we now know as usual that we can actually start solving this problem using any technique, you see. But now, if you are observant enough, you will see that actually this problem that we have here can be written as 5x squared plus 45x minus x minus 9 is equals to 0. Then if I pull out 5x in the first bracket, I'll get x plus 9. Then if I pull out minus 1, I'll get x plus 9, all equal to 0. Then from here I can see now that I have 5x minus 1 and x plus 9 is equals to 0. So therefore, what is x? X is equals to 1/5, or x is equals to minus 9. So we see that these are our solutions. But always remember, it may happen that at times only one of them is true and the other one is false. So always check. So the checking procedure must not be shown, but it's always advised that you do it. So in this case, I will check and see if both of these two values are actually what we are looking for. So to do that, we are going to proceed as follows now. So let's consider the equation that we're trying to solve. So let's consider the equation that we're trying to solve, which is 2x minus 5 equal to 3x plus 4, and see if everything works. So when x is 1/5, what we see on the left, you will get 2/5 minus 5, and you will get 3/5 plus 4. So when you put 2/5, 1/5 both sides, this is what you get on the left and on the right. So let's simplify and see now. So if you simplify on the left hand side, you'll get negative 23 over 5, and the other side also you'll get 23 over 5. Since we know that the absolute will cancel the negative, we can see that the left hand side and the right hand side are fine. So this one checks in correctly. So now let's check if the other one also does check in correctly. So we come in out and say, when x is equal to negative 9, what do we see? So on the left hand side, you put negative 9, you'll get negative 18, negative 5 is equals to, then put negative 9, you'll get negative 27 plus 4. So we see now that we get here negative 23, and on the other side also we get negative 23. So we see that the left hand side and the right hand side are the same. So we see now that both answers, they check in correctly. And what can we therefore say? So therefore we can finally say now that the solution to our problem is x is equals to 1/5, or x is equals to minus 9. You see, so this is exactly how the squaring technique works when it comes to problem solving. You see, so what we have to do now is normally in class, this is one of the techniques that is not normally demonstrated as a technique for solving these equations. So it will be good to actually redo some of the problems that you would have solved using maybe the correct definition or the formal definition of the absolute function, and see if you will always land to these solutions that we have actually discussed here. But before we move on, first I have to point out something. This technique that I have actually demonstrated here, it does not always work all the time. You see that? So the squaring method has limitation, and those limitation is that it can only solve the following types of equation. So it works efficiently for problems of the form the problems that where it is best to use it are problems the form f of x or a f of x is equals to b g of x, or b a f of x is equals to what? Is equals to b g of x, like that, you see. So these are things that you should be very careful with every time when you have to solve. So once there are things outside the absolute function, or like maybe a plus c, you cannot use arrive. So never use it in problems of the form. So it is advised that you should not use these in problems of the form alpha f of x plus beta is equals to alpha prime g of x plus beta of prime, because once you have things that are lying with both beta prime not equal to 0, you see. So every time when beta and beta prime are not equal to 0, these problems can be very complicated when you try to use this technique. So one thing that you should practice is to know the type of problems where you can apply it, and know the type of problem where you don't have to apply it. So I've given you already some clues where you can apply this technique and where you cannot actually apply it, you see. So yeah, this is how one can actually use this technique for solving problems. So now the next thing that we're going to talk about is to demonstrate now how to solve these same type of equation using the method of cases. You see, so that's what we're going to see. Okay, so method of cases now. So what exactly is the method of cases? So the method of cases is based on actually trying to look at particular cases at a certain instant and trying to solve for those particular cases and see what happens. So I can say it is the informal way of using the definition of the absolute function, though actually it is much more easier to use the method of cases to solve problems than to use the original definition of the absolute function. So what we're going to do now is to see how this procedure works. We're just going to jump on to look at examples, and what I'm going to do, I'll try and solve some of the problems that we have solved already. Like for example, I'll say solve 2x minus 5 is equals to 3x plus 4. So that's what we're gonna look at right now, you see. So now let's see how the method of cases can be used to solve problems like this. So to use the method of cases to solve problems like this is how we proceed. So the first thing is we look at case 1. You see that? So the first case, which I always refer as to positive case, is a case whereby you actually take both these two absolute functions to be positive. So remember, if the thing on the inside of the absolute function is positive, you can safely remove the absolute function. So if I take this to be positive, it means I just remain with just 2x minus 5 is equals to 3x plus 4. Then what I do, I just solve this resulting linear equation. So I get minus x is equals to 9. So I see that x is minus 9. So that's my first case. Then I move on to case 2. You see. So case 2, it's whereby you take both sides to be negative. So I'll call this the minus case. So both the left and the right hand side are negative. So remember, every time when the absolute value, when the thing inside the absolute value is negative, then the absolute function will always multiply that by a negative sign. So you'll get negative 2x minus 5 is equal to negative 3x plus 4. But this negative and this negative, they will cancel, which will bring us back to the original thing. So we still get x is equal to minus 9 again. No problem. Now let's look at case 3. So case 3 is one that I'll refer as the plus minus case. So it means you're going to consider that the argument of the left hand side is positive, while is that of the right hand side is negative. So if the argument of the left is positive, it means that you can safely remove the absolute function. You see that? But since the function on the right hand side is negative, it means the to make it positive, we have to multiply by a negative on the outside. So we'll get negative 3x plus 4. So what happens now? So simplifying this, we just get 2x minus 5 is equal to negative 3x minus 4. Then bring this side, we get negative x. 5 minus 4 is 1. Yeah, so therefore x is equal to minus 1. So that's what we get now when we simplify these things. So we get that x is equal to negative 1. So let me see if I did copy it correct. So I said 2x minus 5 is equal to that. So yeah, this is what we obtain now. So now we get that x is equal to negative 1 in this particular case. Then now, the next thing that we should do is we can look at case 4 now, which is actually the last case. So in case 4 now, we're going to take the negative plus case. So which means now we'll take the left hand side to be negative. So if the left is negative, it means I'll multiply by negative on the left. So I'll get negative 2x minus 5 is equal to, then on the right hand side, since it's positive, I'll safely remove that. Sorry, I forgot negative here. So I'll safely remove that to get 3x plus 4. So what happens now? So we see that we get negative 2x plus 5 is equal to 3x plus 4, like that. So what happens now? So I can take this, I'll get negative 5x is equal to negative 1. So we see now that x is equal to 150. You see. So if you look now, using the method of cases, we did not obtain just 2 solutions, but we obtained 3 different solutions. So what are the possible solutions? So possible solutions are x equals to 1/5, x is equals to minus 1, and x minus 9. Whereas the other technique just gave us 2 solutions. Now we have an extra. So which shows that now every time when you solve an absolute value function, you can't really make conclusions every time when you get solutions. You have to check which of these actually are the solutions that you are looking for. So now what we're doing is we're going to check now to see if all these things are solutions. So to check, I'll consider the equation that we're trying to solve, which is 2x minus 5 is equal to 3x plus 4. So what I'm going to do, I'll check first when x is 1/5. So when x is 1/5, put 1/5 on the left, you get 2/5 minus 5. Put 1/5 on the right, you get 3/5 plus 4. Then you can see that you get here on the left minus 23 over 5, and that side you get 23 over 5. So we have 23 over 5 is equal to 23 over 5. So the left hand side is equal to the right hand side. So this perfect solution. Now let's check -1. So to check -1, this is how we proceed now. So we come and say when x is equal to -1, put -1 on the left hand side. So if you put -1 on the left hand side, you'll get -7 is equals to, put -1 on the other side, you'll just get 1. So we see that we have 7 is equals to 1, which is not true. You see, so this is not a solution. This is not a solution. So now we can now check for -9 as well. You see, so we come and say, when x now is -9, what do we see? On the left, put -9, you get -18 minus 5. And then you put it on the right hand side, you get minus 27 plus 4, which we see that it will simplify to -23 and to -23. So the left hand side and the right hand side are the same. So this is another solution. So therefore now we can see that therefore the solution is x equals to -9 or x is equals to 150. So this is how you make use of the method of cases to solve absolute value equations. You see, so every time when you want to solve the absolute value equations, then this is how you play around with the method of cases. You see. So one thing about what that I like about it is that this technique can solve any type of absolute value equation. So it can be used, but you have to be careful now how to employ it, because to make sure that you do not mess up when using this technique, let's look at the following example. Suppose now you are given this example where you're asked to solve the equation 5x plus 3 is equals to 2x minus 1. You see, so now in this problem you have only the absolute value on one side, on the other side it's not there. You see, so how can you now deal with this? So cases are applied only to the absolute function, because it is that function that can either be positive or negative at the same time. Other functions, they just have one sign and that's it all. So which means if you are to solve this problem using the method of cases, this is how you'll proceed. So we'll consider the first case where we consider the left hand side to be positive. You see that? So we consider the left hand side to be positive. So if it's positive, this simplifies to just 5x plus 3 is equals to 2x minus 1. So we see now that 2x will come this side and we'll have 5 minus 2, which is 3x, and negative 3 will go that side. So I can see now that x is equals to -4/3. Then now I look at also the other case 2, where now the left hand side is negative. So we now know that if the left hand side is negative, I multiply by negative that part. So it means I'll have negative 5x plus 3 is equals to 2x minus 1. So I'll have negative 5x minus 3 is equals to 2x minus 1. So I'll get negative 7x is equals to 2. So x is equals to -2/7. So now you see we have only two cases when we take out the absolute value from one of the sides. So we have only two cases to consider now. So which means what are the possible solutions? So our possible solutions are what? So we have x equal to -4/3 or x equals to -2/7. So now let's check who is correct. So to check now, so we know we're trying to solve 5x plus 3 is equals to 2x minus 1. So let's start with when x is -4/3. So when x is equals to -4/3 what we see. So we see on the left hand side, when you put that, you will have negative 20 over 3 plus 3, and on the right hand side you will have negative 8 over 3 minus 1. So simplifying here, we'll have negative 11 over 3 is equals to negative 11 over 3. So the absolute of a negative is a positive, so we have 11 over 3, which is not equal to negative 11 over 3. So we see that the left hand side is not equal to the right hand side. So this thing is not a solution at this instant. You see. So you see the importance of checking now, because you might think that both these two are solutions, but we can see now that one is agreeing to be correct. So let's check the other one to see if it will become a solution. So we come and say when x is negative 2 over 7, what happens now? So when x is negative 2 over 7, we put negative 2 on the left, negative 2 over 7, which will give us negative 10 over 7 plus 3 equal to, then we put negative 2 over 7. So when we put negative 2 over 7, what are we going to get now? So we're just going to get negative 4 over 7 minus 1. So, and then when we simplify, we see that we'll have here 21, which is going to be minus 11 over 7. And here we'll negative 11 over 7. But the left hand side will give us 11 over 7, which is not equal to a negative 11 over 7. So the left hand side is not equal to the right hand side. So this is also not a solution. But these were the only possible solutions that we had. So which means, what does that mean? So therefore, this equation has no solution. So what does that mean then? So what it means, if we were to interpret what's going on here, it might mean something like this. It means if you are to draw these two curves in a Cartesian plane, they will behave as something like this. You will find that maybe if one of the function is like this, then the other one will be something like this. You see, meaning there is no way they can intersect. So if this is your function f of x, then your absolute value of gx will be something like that. So we can see that that's exactly what is going on there. So if you are to take your time and plot these two curves involved in this problem in the same set of x's, you will see that you will get something which almost looks like this, which shows why we don't have a solution. So I think this problem actually it's a very nice problem, because it actually emphasizes on why you should always check that what you have obtained is indeed a solution or not a solution. Because you might think that obtaining things out means that yes, these are the solutions, but we can see now that what we obtained was not actually a solution because it did not satisfy the equation. So it's very much important for you to always make sure that you do this step. Though you don't have to show it explicitly, you can do it on a rough page just to see if things are working perfectly fine or not, like that. Otherwise, yeah, that's how one can solve these absolute value equations using these various techniques. You see, so one thing that I'll just end is that NP, the method of cases, can be used to solve any absolute value equation. So it can be used to solve the absolute value equation. And what you can do now is you can take your time maybe and try to solve this equation. X minus 2 plus 3 is equals to 3 to 2x minus 5. So this is one problem which is different from what we have seen, but still you can use the method of cases to solve this problem and check for your solutions. And then yeah, that's it. So we'll just end it here today. So thanks very much for watching. So yeah, you can also go through the video if it's much useful. It will be good to see your likes or comments on the video. Otherwise, see you next time.